on our Chapter 26 Notes Part 3, we want to talk about the last test that we're going to do. It's the chi-squared test of independence. Okay, so we have now run we've now talked about 3 different kinds of tests. And so before we dive into that, I think I would like to give you an idea of what's the difference between them all real quick before we get going. So I drew this up here. You don't have this in your notes, but let's look at these from left to right. Okay, so looking over here on the left, chi-squared goodness of fit. That was when we had just one variable. We had claimed percent. Okay, we had the claimed percent. We had to put our data in list 1 for our counts and list 2 in our expected counts, and we ran the chi-squared goodness of fit test. Okay, so it looked like this. We had all our counts and then our column of expected counts. That was the goodness of fit. Key there, they give us the claimed percent. That's like a dead giveaway. All right, then secondly, yesterday we talked about this middle one here, chi-squared test of homogeneity. So that is, again, just one variable, but you do not have the claimed percentages. And so we end up having to use a matrix because we'll have something like this. Our regular versus our peanut butter and our peanut. So we have these 3 different types, 3 different groups, but then we've got brown and not brown. Okay, so are these brown and not brown, as opposed to all the different colors, which is like what we're going to do. So we had just one variable, the type of group. Okay. Today, which is this farthest one here on the right, chi-squared test of independence, we have legit 2 full variables. So we will still use the matrix. Everything is done the same. The computation, the conditions, everything is the same except for what you call it and some of the language that you use. So, but look at the difference of how this matrix looks. It has the variable type of M&Ms, and it has the variable color. So it has 2 full variables, and I am seeing if the type of M&M is independent of the colors of the M&Ms, the distribution of the colors of M&Ms. Okay. All right, so that is a summary of those differences, and we'll address this again later. So let's go on over here. Again, with our chi-squared test of independence, we have 2 variables, such as this example, car type, the American, Asian, European, and driver, students and staff. Okay, 2 variables. Here is another one. It's classification on the Titanic. And it's not alive and not alive, but the floor assignment. So we've got upper deck, lower deck, basement. Okay, so we've got 2 full variables. Is the floor assignment independent of the classification? The assumptions, conditions, and calculator computations are identical to the chi-squared test of homogeneity. So we'll zip through this real quick and just kind of hone in on the differences of the language. So look at this problem here. The table below shows the rank attained by male and female officers in the New York Police Department. Do these data indicate that men and women are equitably represented at all levels of the department? So I do have 2 variables here that I want to see if they are independent of each other. What are my 2 variables? Gender and rank attained in the NYPD. Good. Very good. So those are my 2 ones. By the way, let's do the degrees of freedom real fast. Rows minus 1. How many rows do I have? 6 rows. Do not count the totals. So 6 minus 1, and columns minus 1. Okay, so my degrees of freedom are 5. 5 times 1. Okay, so we're going to go on to the next page and write down some stuff so that you can see how the wording looks a little bit different when you run yourself a hypothesis test. So if we take a look at this, let's walk through it. So our null hypothesis is that gender and rank in the NYPD are independent. gender and rank in the NYPD are independent. Okay, and so then our alternative would be what? They're not independent. So for our null, the fact that you are a male versus a female does not change the rate at which you are going into a particular rank. The alternative, gender and rank, are not independent. Yes, but you cannot say they are dependent. That's a no-no in statistics. If you say one thing depends on the other, then you are saying that there's a direct functional relationship, and we don't have a one-to-one perfect functional relationship in real life, for the most part, or in a lot of real life data. Okay. All right, so now let's take a look at conditions, because there's a couple things interesting about that. So randomly selected men and women were assumed, because those are my two groups that I'm indicating as the driver behind the ranking. And when I do my independent, I got to do it for both of those groups. Okay, remember, these are my two groups of data. So I'm saying that 31,766 is less than 10% of all such men in the NYPD. I don't know if that's like ever or what, but, and that 5,613 is less than 10% of all such women in the NYPD. And I have two groups, so what am I going to say about the males and the females? They are independent of each other, and while you're finishing writing that out, I had some good discussion in first period today. They said, well, am I supposed to write that the men and women groups are independent of each other? Because aren't I doing a test for independence? Okay, so I love that kind of question. That makes me go, man, I don't know. Let me think about that. So here's the deal. What we're saying is that, oops, 2 pages over. Yeah, we're saying that the men and the women, whoever's in this group, that these counts are not being counted in this group. These two groups are independent of each other and not being double counted. This problem is not about men versus women being counted in these two groups. This problem is about the two variables being independent. Is gender independent of rank? That's why you still say men and women are independent of each other. See? Man, I just love it when people think, and makes me wonder, and then I get to try and figure that out. Okay. Large enough, as you could see from that other matrix, all expected counts are greater than 5, so the chi-squared model applies. All right, and we would go put that into our matrix, calculate a chi-squared test. Here's your information already, so we don't have to waste our time doing that. Our p-value is 290.13. Oh, sorry, that's chi-squared. 290.13. Yeah. P-value is 1.32 times 10 to the negative 6. With degrees of freedom 5, you guys had already figured that out. So what's my decision going to be? Okay, so with the p-value less than alpha, I reject, what am I rejecting? That they are independent of each other. Okay, so I'm rejecting that gender and rank in the NYPD are independent. Okay. So I have evidence of the alternative. So I have evidence that the alternative is true. But I kind of reworded it so it was a little bit more made kind of some common sense. So there is evidence that gender affects the rank in the NYPD. That's what it means to be not independent. They are affecting each other. The gender is affecting the rank. It's not happening at the same rate. speak for everything because I don't know, but I would imagine that you would have to decide kind of your wording for one driver versus the other. Okay? Okay, now, suppose I want to say more information, more specific information. I wonder really what is going on specifically amongst those ranks. What do I do to get that more detailed information? Standardized residuals. So let's remember the formula was the observed minus expected over the square root of expected, and I've done that for all of those. And I also highlighted the ones that are negative, like I put, not highlighted, but I mean you can see the negative. What does a negative residual mean? The observed is less than expected. So do you see how there's kind of a pattern? You can see them kind of grouped together. So that does seem to give me an indication of something happening there with males versus females. I mean, and you don't have to write all those numbers down. I know this is just an example, but so I wrote, it is evident from the standardized residuals that males are underrepresented in those lower ranks. You see those lower ranks have the negative residuals? And overrepresented in the upper ranks. Now, I could say something else. What's another statement I could say? The females are what? Overrepresented in the lower and underrepresented in the upper ranks. Absolutely. So there's multiple sentences that I, as your lucky grader, get to read and decide if your mind is making a true statement or not. Now, if these positives and negatives had been just all over the place, you know, skipping around, positives and negatives up and down, every other one, that would kind of not be a pattern that I would have noticed a situation. That would have been a hard thing to say, yeah, there's a pattern going on. So here we had a clear pattern of what was happening, but if the negatives and positives were all over the place, not so much. All right, last thing. We want to make sure we have a clear indication of how to tell the difference between the three tests. So we're going to read some problems and label them as chi-squared goodness of fit, homogeneity, or independence. Yes, ma'am. Haha, nice. That's so good. Yes. If there was really no pattern going on and those negatives and positives were just kind of sprinkled all over the place, you would think there's not really a relationship going on between the two things. So you would say that gender and rank, it should have been the decision to be independent of each other. They shouldn't have really been affecting each other. Very good. Okay. Now let's do this one here. So here is going to be some situations. Let's review. I already talked about this. Our chi-squared goodness of fit is that single variable where they give us an expected distribution. They give us the claimed percentages. The homogeneity is where we just had one variable with several groups, one categorical variable amongst the several groups. And all right, and then our chi-squared test of independence, of course, we've just been talking about, is those two separate variables, okay? Got it. So let's read a couple of these. Unfortunately, they're kind of redundant and have the same one over and over again, so hopefully I can kind of guide you through some things to still help you with this. A restaurant manager wonders whether customers who dine on Friday nights have the same preference among the four chefs' special entrees as those who dine on Saturday nights. One weekend, he has the wait staff record which entrees were ordered each night, assuming that the customers be typical of all weekend diners. He'll compare these meals chosen on Friday and Saturday. So, what are we dealing with here? We got Friday, Saturday nights. Okay, so that's one variable. Do we have another variable? Yeah, the chef's entrees. We're wondering if they're, chosen that same way. So if I have got those two variables, then it's going to be chi-squared test of independence. Okay? We're wondering if that day is affecting the ratio or the rate at which those entrees are chosen, or if it's independent of those, I guess I should also say. Okay? Here's another one. This one's interesting because I think depending on how you interpret something on it, it could go either way. There are 3 lots of equal size. Lot A is next to the building. Lot B is a bit farther away, and Lot C is on the other side of the highway. Consider Narnia. You gathered data about employees at middle management and level and above to see how many were assigned parking in each lot. Okay, so we've got A, B, and C, and so then why do you say homogeneity? So I could see that this right here, how you interpret middle management level and above makes this debatable because I could see it organized in these 2 ways. If you say, okay, I got middle management and above, then this is another variable here that I have. If you say, okay, I got middle management and above and not middle management and above, then I would see this perhaps as being, which is what you had described, everybody else. I would classify this one as my homogeneity. So I think sometimes what you call it is debatable. I would hope that the ones that they have on the AP exam are more obvious, clear cut between homogeneity and independence, especially because one year they did mark off if you called it the wrong thing. So that's why we try to have these discussions. Yes, ma'am. No, I don't think so. You just have multiple things in that particular direction. You don't have to do all of them. Okay? All right, so I personally had interpreted it as the independence way, but you are welcome to write that one up however you wish. So I had said it was ABC versus employment lot type versus employment type. Okay? Now, let's do this one more here because it kind of gets into something interesting. Is a student's social life affected by where the student lives? A campus survey asks a random sample of students whether they lived in a dormitory, in off-campus housing, or at home, and whether they had been out on a date 0 times, 1 to 2, 3 to 4, or 5+ times in the past 2 weeks. So those are categorical or categories of dating that you would tally yourself into. So what do we got going on here? If it was goodness of fit, it would give us some like percentages, 13% for this, 20% for that. So what do we think? I think it's still 2 variables. I have too many of those. I'm just like, hey, you're going to see all these different kinds, and nope, it's the same thing over and over. Okay, date amount versus type of housing makes it independent, but I like this next one here. Consider the scenario in part C, but what if the students were asked the number of times that they went on a date? The number of times. So instead of a student telling me the 0, 1 to 2, 3 to 4, 5+, they just said, how many times did you go on in a week? How many times did you go? How many times did you go? How many times did you go? What was going to happen? What would we end up doing with those numbers? We would end up averaging them, and I would get, if everybody in here told me, if every student told me their number of dates, then I would end up averaging the number of dates that the dormitory students go on, averaging the number of dates that the off-campus students go on, and averaging the number that the at home. That would make it 3 means, so not chi-squared. Okay, multiple means is a nova. We won't even do that. If all it had asked for was dorms and off-campus, then that could be 2 means, and I can do a 2 mean problem. How would I do a 2 mean problem? 2 sample t-tests. Let's move on down here. I did consider this one homogeneity because it asked for residential versus non-residential students, and then the humanities, social science, or science. But I like this very last one. So let's skip G and look at H. It's an addition to G, but we'll just pretend like we did G. The brokerage firm also wants to know if the type of account affects the size of the account in dollars. So if I'm talking about the size of the silver accounts and the size of the gold accounts or whatever, how would that be handled? Size of the accounts in dollars. Size of the accounts in dollars is to see if the average size of the account is the same for the 3 different types. What does that mean? It's average, not categorical, not chi-squared at all. Okay, so 4 times in the notes today I have referenced be mindful of averages because they are not categorical. All right, so I have shortened your assignment because I'm just that good. And you're going to do page 18, okay, page 18, and then you will also do the warm-up, which is on pages 21 and 22, okay? So do page 18 and 21 and 22. I wanted to talk to you about problem on page 18. Okay, let's take a look at that page 18 real quick. Okay, so when you do your conditions, use these numbers up here in our observed amounts. These are birth order and their college major choice. Okay, so I've got 4 groups here. So I'll be saying this is less than 10% of all firstborn children, and this is less than 10% of all secondborn children, and so on. So that's a bit annoying. But I wanted to also reference this expected values. What is the problem with these expected counts right here? They're what? Not that they're decimal, because the expected's on average. They're less than 5. That's the problem. Dun, dun, dun. Okay, so what am I going to do? I'm going to say, ooh, I'm concerned that all of the, some of the expected counts are less than 5. So, but if this was if the chi-squared model applies, then it would go like this and continue. Okay, so there you go. By the way, this will ask you about the standardized residuals. If you can tell me the formula right now, I'll leave this up here and let you just, because otherwise you'd have to do 16 of those formulas by hand. So what do I do to get each one of those little boxes? Good. Observed minus expected over the square root of expected. You would have had to have done that 16 times. But I did that for you. So you're welcome to write that down, and then you'll be making a conclusion on that.